this is a video to look at the various methods of testing the assumptions for multiple regression, as illustrated on what is slide 12 and then the 5 slides after this. I mean, this can get very, very technical, but it can also just be sort of in a practical sense in that because these models kind of get complicated, you do want to make sure that these assumptions are not grossly violated. So this is just kind of looking at and checking at things a little bit more. The first thing to check is whether or not the outcome variable is normally distributed. And that is really quite a simple thing to do. I'm going to go back and forth between SPSS. I'm just going to continue using the nursing data, even though it's a small data set. So, I mean, all I want to do here is look at my outcome variable, which is score, and I just literally want to look at the descriptives. And so just going back to the module 0 material, we would just be looking at, you know, what is the distribution of this outcome variable. Now this is, I mean, it's such a small data set that this is not really a very valuable exercise, but, you know, just look at we're not going to get much out of this because there's only 5 values. I mean, I would say, you know, what we're looking for is normality distribution. I mean, obviously with 5 values, it's pretty ridiculous to even be, but we see that the scores are pretty evenly distributed. And actually, surprisingly, even with 5 values, there is a relative indication that this is, you know, the middle is around 500, and then, you know, the dispersion from that is pretty even on to the left and to the right. If we saw something like 490, and then we had like 4 of them being at 490, and then 1 of them being at 670, we would see a violation of normality, and that, you know, the distribution would clearly not be like something symmetric. So that would be a little concerning. Okay, so that's the first assumption. Literally, is to just look at the outcome variable, and yes, it's reasonably normal in this case. The second thing is to look at the residual patterns. Now that came from the simple linear regression, but we can do it with multiple regression too. And so to do that, I'm going to run the regression model again. I'm going to go to Analyze, Regression Model, Linear, and actually I think I already have my residuals there, but let's do this again. And I don't actually want that R-squared change thing right now. I don't want that. I do want to save my residuals, and I already have my unstandard. I already have my residuals saved. Okay, and then plots, and I want to do. We did this in the simple linear regression, so I want to do on the x-axis just put my dependent variable. I know that's opposite, like, you know, technically dependent variables are predictor, but we can do that. That's fine. And then I want to do the residuals on y, and I just want to look for a funny pattern. And so I'm going to hit go. It's going to run the model again that we don't really need to do, but I want the residual plot. And here we go. Okay, so this again is a residual plot. Like I said, it's only 5 data values. So you want to look at your residuals. These are standardized. It doesn't matter whether they're standardized or unstandardized for this purpose anyways. Because standardizing is just changing. It's not going to change the distribution of the residuals. And so this is not showing me anything in terms of a deviant pattern. I mean, yeah, there looks like a line going down it, but with 5 data values, it's not that important. So you just want to take a look at the plot of the residuals just to see if there's any really, really funny looking pattern as a diagnostic of your model. Okay. The next assumption is the linearity of x to y variables, and this goes back to the scatter plot idea. I'm trying to connect everything together here, and what we want to do is we want to do that matrix plot of the scatter plots, like we did when we did correlations and scatter plots a week or so ago. So let's go under graphs and let's do legacy dialogues and do no, we want the chart builder. We want the fancy plot. So we want the fancy plot, and here Okay, so I dumped GPA, age, and score all into the matrix plot, and I used this little matrix plot I showed you a couple classes ago, and I'm going to hit OK. Now, all we want to do here is we want to make sure that we have a linear pattern of sorts. Because we're predicting score based on age and GPA, we want to look at score as y and then GPA and age as x values. And what I want to look for is some type of linear pattern. So I'm looking down here at score on y versus GPA, and this looks at least decently enough, because remember, we're doing a linear model where we're looking at a linear relation between this variable and this variable. And so there's a linear model between GPA and score as well as between age and GPA. And that's what we're looking for. What we don't want to see is like a quadratic or a funny pattern here either. We want to at least verify that there's some type of linear relation between our dependent and independent variables. And so the other thing to look for is multicollinearity. And that actually can sort of be seen at the scatter plot. What you don't, that I just did, what you don't want to do is you don't want to see the x variables having very strong linear correlations, because what basically that means is that they're conveying the same information. So you wouldn't want age and GPA to be just in a straight line. They're not. I mean, there might be, this is a five-point data set, so it's very weak in terms of the statistical, diagnostic ability. But you don't want to see the x variables highly correlated, because if the x variables are highly correlated, if you think about it, they're basically they're so related that they're kind of conveying the same thing. So that can be an issue in models. That's just something to consider. There's a lot more statistics involved in collinearity diagnostics that we're not going to do for this class. But just be aware that when you do a multiple regression, this becomes an issue, because with a one variable regression, you just have one variable, so it's like, okay. But when you have multiple x variables, you can have them that are so related they're conveying the same information, like height and weight. Okay? And then last but not least, the assumption 5. This one really isn't that much of a problem. It just basically means that student A, B, C, D, E are not the same student in this case. So they're not, we don't have like a paired dependent case going on here. And that's all that assumption means. Okay. So these are just the basics of a little bit of diagnostics and looking at the assumptions when you do a multiple regression model to make sure that the regression model is valid.